Hi everyone, welcome to another video brought to you by Math Iconic Institute. In this video, we'll be discussing some other divisibility rules. In the last video, we discussed that of 2, 3, 4, 5. So in this video, we'll proceed and move to the divisibility rule for 6, 7, 8, 9, and 10. So let's start with 6. The rule goes thus. A number is divisible by 6 if it is divisible by 2 and 3. That's because 6 equals 2 times 3. So once the number is divisible by 2 and also by 3, we can conclude that it is divisible by 6. So we have some examples here. The first one is 36. 36. Is it divisible by 2? Yes. Because that of 2 says that if the number ends in an even digit, then it is divisible by 2. And 36 ends in 6, which is an even number. So it is divisible by 2. It is divisible by 2. And the second part, is it divisible by 3? Yes. That of 3 states that the sum of the digits has to be divisible by 3. Let's sum its digits up. 3 plus 6, and that is 9. It is also divisible by 3. So we can conclude that it is divisible by 6. You can confirm that by saying 36 divided by 6, that's 6. We have 210. 210. Is it divisible by 2? Let's confirm. Yes, because it ends in an even number. Remember we said 0 is an even number. Second part of the rule, is it divisible by 3? Let's confirm. As for 3, what do? We add the digits. 2 plus 1 plus 0, and that's 3. So it is also divisible by 3. We can conclude that it is divisible by 6 also, since it satisfies the two conditions. The third number we have here, 102. Is it divisible by 6? Let's find out. 102. Is it divisible by 2? Yes, it is divisible by 2 because it ends in an even number, which is 2. Is it divisible by 3? Let's confirm. As for that of 3, what do? We sum up its digits. 1 plus 0 plus 2. That gives 3. It's still divisible by 3? Yes. So we can say it is divisible by 3. So we can now conclude that 102 is divisible by 6. So let's confirm if that is true. 102 divided by 6. 6 in 10, that's 1. I mean that 4. 6 in 42. Also, let's confirm if 42 is divisible by 6. Even though it is 7, 6 in 42 is 7. But let's confirm that using our rule. 42 ends in an even digit, which is 2. Which is divisible by 2, right? Is it divisible by 3? Let's confirm that. Sum up with digits. That's divisible for 3. Add up a digit. If it is divisible by 3, then that number itself is divisible by 3. 4 plus 2. That is what? 6. Is it divisible by 3? Yes, it's divisible by 3. We can conclude that 42 is divisible by 6. And then you can see 102 divided by 6 gives 17. The next one we have 1296. Is it divisible by 6? So the first step is it divisible by 2? Yes, because it ends in an even number, which is 2, which is 6. Is it divisible by 3? Let's confirm. That of 3 states that a number is divisible by 3 if the sum of its digits is divisible by 3. So let's sum its digits and confirm that. 1 plus 2 plus 9 plus 6. Add up. 3 plus 9 plus 6. That's 18. Is 18 divisible by 3? Yes, it is. So 1296 is divisible by 2 and also by 3. So we can conclude that it is divisible by 6. Now, it is worthy of note that if a number might be divisible by 2 and not divisible by 6. And that's in the case where the number satisfy the divisibility rule for 2 but not 3. For example, we have 40. What is divisible by 2? Because it ends an even number, 0, but it's not divisible by 3. So we can conclude that it's not divisible by 6. Because for it to be divisible by 6, it has to satisfy the divisibility rule for 2 and 3 together, not one of them. So numbers like 80, 100. So they are divisible by 2, but not 3. So since one of the condition is not met, it's not divisible by 6. On the other hand, if the number meets the divisibility rule for 3, but not 2, also it's not divisible by 6. For example, you have an odd number, say 33, for example. It's divisible by 6, by 3. But when you sum up with a digit, 3 plus 3, you have 6. It's divisible by 3, right? Is it divisible by 2? No. Why? It does not end in an even digit. So we can conclude that this also is not divisible by 6. So for that of 6, it has to satisfy those two conditions. It is divisible by 2 and by 3 together, not one of them. If one of the conditions is not met, then it's not divisible by 6. Now we move to that of 7. As for 7, there are two methods of checking for that. There are two methods of checking for 7. The first of the two methods is this. So we multiply the last digit by 5 and add the result to the truncated number. So if the final result is divisible by 7, then the original number is also divisible by 7. So let's see how we do that. Let's confirm for 49. Let's confirm for 98. Let's confirm for 42 and 343. So for A, we have 49, right? What's the last digit? It is 9. So the rule says 9 times 5. Multiply the last digit by 5. 9 times 5. Add the result to what? The truncated number. That is the number that is left. In this case now, what's the number that is left? 4 is left. Add it to 4. 9 times 5 is 45 plus 4, 49. So 49 is divisible by 7. Just like we know, 49 divided by 7 is 7. For B, 98. Let's confirm. What's the last digit in this case? It is 8. So 8 times 5. Multiply the last digit by 5. Add it to the truncated number. So 8 times 5. Which number do you have left? That is 9. So add it to 9. 8 times 5 is 40. 40 plus 9 is 49. So is 49 divisible by 7? Yes. That means 98 is also divisible by 7. For 42. 42. What's the last number? It is 2, right? So 2 times 5. Multiply that. 2 times 5. Add it to the remaining number, which is 4. 2 times 5, 10, plus 4. That is 14. Right? So is 14 divisible by 7? Yes. That means the original number, 42, is also divisible by 7. Next number we have is 343. For 343, what's the last number? Last number in this case is 3, right? Multiply 3 by 5. 3 times 5 plus. Now, let's be careful here. So the rule says multiply the last digit by 5. You have 3. In this case, will be the last digit. 3 times 5. Add it to the truncated number. The truncated number simply means the remaining numbers, the remaining digits, take them as a whole number. So I'm not saying 3 times 5 plus 4 plus 3. No, take the remaining number as a whole, 343. For example, if you are testing for 1175, right, you say 5 times 3 times 5, right, then plus 117. That's why we say it is a truncated number. It's a number that another number has been taken from it. Normally you have 343. So once you take 3 away, the 34 is a truncated number. You actually truncated it. So it is 34. So we're not saying 3 times 5 plus 4 plus 3. No, 3 times 5 plus the truncated number. So you take 34 as a whole number. So even if you have 5 digits left, you take the whole 5 as a whole number. That's what we mean by a truncated number. So let's proceed. So let's add. This is equal to 3 times 5 is 15 plus 4 plus 3. And that is 3 times 5. Oh, sorry. 3 times 5 plus 34. No, make that mistake. It's plus 34. Plus 34. So 34 plus 15. That is 49. Is it divisible by 7? Yes. That means the original number, 343, is also divisible by 7. Now, someone might ask that we should be able to detect if 49 itself is divisible by 7. So I'll give you a second method by which you can do that. So the second method, so the method 2. So with that second method, we can even know if 14 is divisible by 7. So for the second method, double the last digit, subtract the result from the truncated number. Also take note here, it is a truncated number. So let's see. So the numbers we had then was 49, 98, 42, and then 343. So let's see. So this rule says that we have to double the last digits. For this case now, 49, 9 is the last digit, right? So double it, 9 times 2. What do we have? That is 18. So subtract the result from the truncated number. And I said the truncated number is simply this 4 that is left here. So that is 4 minus 18. The result you got from doubling the last number, you now subtract it from the truncated number. What's 4 minus 18? That's minus 14. Right? So is minus 14 divisible by 7? Yes, it is. So we can conclude that 49 is divisible by 7. Second one is 98. The last number here is 8. Double it. That's 8 times 2. What do you have? 16. Now subtract 9 minus 16. What do you have? Minus 7. Is minus 7 divisible by 7? Yes, it is. Then 98 is divisible by 7. For 42, what's the last number in 42? Last number is 2. Double it. 2 times 2. What's the result? 4. Subtract 4 from the truncated number. 4 minus 4. No, the number left is here is 4. 4 minus 4 is 0. Is 0 divisible by 7? Yes. 0 divided by 7 is 0. So we can conclude that the original number 42 is also divisible by 7. 343. What's the last number here? It is 3. Double it. 3 times 2. You have 6. Now subtract 6 from the truncated number. In this case, the truncated number is actually 343. So the main digits you take them as a whole number, like a single number. So don't say 3 and 4 separately. No, saying 34. So we are saying 34 minus 6. And that's what? That is 28. Right? 28 also. Let's see if it is divisible by 7. 28 also. What's the last number in 28? Last number is 8. Double it. 8 times 2 is 16, right? subtract it from the the truncated number. 2 minus 16, that is minus 14. Right? Once you know this is also divisible by 7. You can remember there was an example here, 14, right? I intentionally left it as 14. So we can proceed further with this method to say, as for 14, let's take a 14 also. Last number here is 2, right? Is 4. Double it. 4 times 2. That is 8. Now subtract it. 1 minus 7 minus 8 is what? Minus 7. Is it divisible by 7 or not? Yes, it is. So with this second method, you can get to the root. So no matter how high the number is, you can always get to the lowest, the least, which is 7. Unlike the first method, it is useful for numbers that are um, for 3 digits, from 3 upwards. But as for this, you can use it for even 7 or 14. For 14, you can use it to be able to get if it is divisible by 7 or not.